Hello, everyone. Thanks for joining the session today. I am Gautam Shanmugam, Product Go-to-Market Specialist for Amazon NoSQL Databases. And I have along with me Pete Naylor, our Senior Product Manager on the DynamoDB team. Pete, do you want to say hello?
Hey, everybody. Yeah, as Gautam said, I'm Pete Naylor. I'm a product manager on the DynamoDB team. I've had about 4 years of experience at AWS, mostly supporting customers with their use of DynamoDB. I had the unusual experience of actually supporting Amazon.com as a customer of AWS and worked through many of their big database modernization projects with them. Really got to love this concept of serverless NoSQL databases. And so that's why I'm here today. Really looking forward to the conversation.
Cool. Thanks, Pete. So in today's session, we will discuss why and how customers are building modern applications using Amazon DynamoDB and Amazon Keyspaces. Please feel free to post your questions in the chat. We have our chat moderators who can help answer it right away, or we can also save it for the Q&A section at the end. Without further delay, let's dive deep in. Let's first talk about three major trends that impact the way we had thought about data. First, there is explosion of data. You have to track a lot of data that comes from business applications or smart devices that generate real-time data. By our estimates, data grows 10x every 5 years. And to take advantage of all the data, you need to be able to partner with someone who can help you harness the large volumes of data. Second, microservices are changing the data and analytical requirements. Microservices let many companies break down a complex problem into independent units so that their developers can operate in smaller groups with lesser coordination. And how that helps? They can respond more quickly to problems and innovate faster. And when these developers break down their monolith applications, they tend to pick the right database purpose-built for the job instead of choosing a one-size-fits-all legacy database.
Yeah, Gautam, one of the things that I really like actually about the diagram in the middle of this slide is the way that it lays out the architecture. It kind of demonstrates one of the best practices for microservices and data storage. One of the things you really want to do when you're moving towards this type of architecture is to make sure that there is isolation of the backing data stores between the microservices. For example, you don't see lines going, multiple microservices accessing one of these databases directly. Usually what you want to do is have a data store that's particular to a certain microservice. If other microservices need access to that data, they should go through an API which is controlled by the service which owns the data store, if you like. And one of the things that's difficult about tracking to this particular best practice in a traditional type of an infrastructure is that you kind of wind up with maybe a cluster of self-managed servers, a database that backs each of these microservices, and not all of the microservices are going to be particularly busy. So you wind up with a lot of different separated, isolated infrastructure here that gets very difficult to manage. It multiplies, and it's often very much underutilized and somewhat expensive. So what's really nice is if you can get to a point where you can maintain that isolation using a more of a serverless type of a resource model. And we're going to talk some more about that as we move through this. I do see sometimes where this becomes a problem, people start to make trade-offs. They end up, using the same data, the same database, the same infrastructure for each, or for multiple microservices, and that's really not a great path or a good habit to get into in terms of your long-term success with microservice architectures.
Yep, totally agreed. So. And coming back to the slide, the third and final trend is the rapid rate of change driven by DevOps models. Many businesses are transforming IT to a DevOps model that introduces a fast rate of change. So the data platform they choose should be able to accommodate that rapid change that they're bringing to their businesses. And that's with data. Let's see how application architecture and patterns have evolved. In the 70s, mainframe was a predominant way of building applications. Then in the 80s, client-server model came in and significantly changed the way applications were built. Then in the 90s, the internet arrived, and as a result, three-tier application architecture emerged. But when you see over these years, client and application code became more distributed, yet the underlying data model was still predominantly structured, and the database, it remained a monolith. The thing I would like to point out here is if you think about it, for almost 3 decades, people typically build applications against a single database. So what has changed now? Fast forward to today, microservices architectures are how applications are built in the cloud, and microservices has finally reached the database part. And the developers today are building not in monolithic ways of the past, but instead with microservices, they are composing different elements together using the right tool for the right job. And also the expectations have changed a lot, right? When it comes to both developers as well as the end users of today's applications. The latency requirements are much lower, that is in milliseconds or even microsecond levels, and they're expected to handle thousands or even millions of transactions per second. These expectations have resulted in modern data platforms with specialized storage and compute layers optimized for specific use cases. This is because a developer never has to trade off functionality, performance, or scale whenever required. So, Pete, when we talk about this need for a modern data platform, what are the key outcomes customers get out of it, and what are the developer challenges that would drive the need?
Yeah, great questions. So, we've already discussed the trends that are associated with these changing architectural patterns for application development and how this results in new requirements for your indexed data storage. As customers are looking to the future, it's important for their success to build on a solid foundation, to apply, a modern data platform. At AWS, we have a purpose-built approach to this. We're building a lot of different database technologies to offer a broad spectrum of solutions to customers because we recognize that while data might be used in different ways throughout a business, the best results are going to come from applying the optimal technology for each of these different data operations needs and indexing needs. We've seen that there are really two aspects to making great progress. The first is that you have to understand there are technology options, and that's part of what we're sharing today. But also, you need to understand that this is a cultural change. It needs awareness and it needs leadership. You have to set goals around this and know where you're headed or where you want to get to. Much as the shift from monoliths to microservices has required. It's not just something that will happen of its own accord. So, when we look at the technology, then, the outcomes that customers are looking to achieve from use of one of these modern data platforms is that you really want to be able to scale seamlessly. It doesn't necessarily mean that every data store is going to have massive scale, but what you don't want to build in is limitations, ceilings, right? Things that you might regret later. If you can find ways to make scaling not a painful experience, then that's definitely going to be a great thing for you in the longer term. You want to have consistent high performance because your customers demand, a great experience, particularly when you're talking about online transactional types of patterns, things that are interactive, websites. We've seen that if you have a complex website that takes a long time to render or your ordering platform is slow, it actually drives customers away. You will lose business over these things. So it is incredibly important. You want to reduce risk and achieve that with increased reliability, and you want to build that in as a basic component to everything you're building. And you need to be nimble and architect the environment to be somewhat future-proof as much as you can, right? To avoid re-architecting applications as the business grows and changes, and to unblock innovation. Having said that, one of the things that we can see, when customers start to tease this part and think about where do I start with this modern data approach, you don't want to try to boil the ocean. Honestly, in any kind of a complex enterprise, you're going to have a lot of different requirements, a lot of baggage, a lot of things that have grown as tech debt over the years. If you fail to make any kind of movement forward because you want to come up with the perfect solution that covers everything, that's probably never going to happen, because things keep changing, right? And making change takes time. It's really important to make a start. Sometimes applications are going to evolve in new directions, and technology is going to improve rapidly in the years to come. Sometimes we're going to learn differently as we move forward. But if you choose a platform that gives you flexibility and a platform that continues to grow and improve over time without a lot of investment from you, none of this is a one-way door, right? You have the option to make change later, and you're not stuck in something that's very inflexible. So here's the second aspect here, that the culture, that is a huge aspect of achieving this modern data platform. Sometimes people who are very accustomed to their current solutions and technologies are resistant to change, but there's no reason for fear. The path that I have seen repeatedly in working with customers through these goals is that, these important technical resources that you have in your team can apply their expertise in ways that make more of a difference for the business, instead of spending time on heavy lifting. They can make a bigger difference for their company's goals, and they can do things that really delight your own customers. People who are data experts remain incredibly valuable. We see them focusing on learning new technologies, serving in a more of a consultative role for developer teams on matters of data integrity, schema, etc., and finding ways to derive greater value from all of that data as something more akin to a data architect. So people with these skills are in increasingly high demand.
So when we talk about how data and applications have evolved, it also comes with a set of challenges that customers face in several ways, starting with scalable elasticity. There needs to be a flexibility to scale your databases up as the data volume or uses grow, and as well scale the resources down during seasonal lows without being locked into a fixed cost model for infrastructure and licensing. And then there are performance issues. Business stakeholders also always need fast access to insightful data. A common drawback of legacy relational or NoSQL databases is that the performance is negatively impacted as the databases grow in size or throughput. You have to upgrade to larger machines, but that will contribute to increase in cost. Finally, developer efficiency. When developers have the right database technology at their disposal, it enables them to be much more efficient. They mainly need to be freed up from the limits in scale, performance, schema flexibility that they are bound to when they're using a legacy database. And say, for example, customers running legacy database environments, both on-premises or self-managed in the cloud, they have to take care of provisioning, managing database solutions, ensuring high availability and security, which is all a time-consuming process and involves a ton of management overhead. Also, they ultimately drives up the total cost of ownership, right? By using people resources on management tasks instead of investing that time to innovate for their users. So in this presentation, we will discuss how our purpose-built databases, both Amazon DynamoDB and Amazon Keyspaces, can help you address all these challenges. Starting with scalable elasticity. So both DynamoDB and Keyspaces has a simplified pricing model. The cost you pay is mainly for data storage and throughput usage. Storage calculation is really pretty straightforward. You just pay for the GB of data you store each month. With throughput, there are two billing options. You either provision your table capacity, or you use the on-demand mode and forget about provisioning entirely. With provision mode, you tell the tables how many reads and writes you're going to do per second in the form of read and write units. When it comes to provision mode, there is a trade-off between functionality and cost. For example, if you over provision, there might be unused capacity for which you will still be paying. But if the provided numbers are too low and there is more than expected user traffic, some of your requests might throttle. But throttling is not always bad, right? It's fundamental to your microservices architecture. Let's say you have complex microservices. This throttling mechanism can actually help you by being the guardrails to avoid any overutilizations. And for scenarios like that, provision mode also has the nice option of auto scaling that dynamically adjusts your throughput capacity for your tables on your behalf. And that happens in response to actual user traffic. So in auto scaling, you define a scaling policy to tell when and how the table should scale. It has a utilization setting. Then you also define a minimum unit below which the table doesn't scale down and a maximum unit above which the table will not scale up. So you specify all these guardrails to have the entire control on how your table handles throughput capacity. To add on, you can also use scheduled scaling policies to schedule either a one-time or a recurring action to change the min and max units to support periodic spikes in your workload. Looking at the graph here, a well-configured auto-scaling table would look like this. The blue line is the actual user traffic. The outer red line indicates the cost you will be paying with either DynamoDB or Keyspaces. And the green portion will be the cost you would be paying extra if you're using any self-managed database on EC2 or on-prem. The reason you have to provision the clusters for peak workload most of the times when you are managing it yourself. On the other hand, there is on-demand capacity mode that is capable of serving thousands of requests per second without any capacity planning. It offers a simple pay-per request pricing for read and write requests so that you only pay for what you use and not what you provision. This makes it easy for you to balance cost and performance. So for tables using on-demand mode, it instantly accommodates your workload as they ramp up or ramp down to any previously observed traffic levels. If the level of traffic hits a new peak, the service adapts rapidly to accommodate that workload. So some good candidates for on-demand mode would be your unpredictable workloads or your mission critical applications that can burst with sudden high traffic, or even your dev and test environment, which see only sporadic activity and not used on a regular basis. So Pete, what about performance?
Yeah, absolutely. Performance is another key thing that we're looking for from DynamoDB and Keyspaces, right? And certainly DynamoDB, having been around for some years now, back in 2012, it was released to GA. We've experienced some pretty extreme scaling needs around things like Prime Day and Cyber Monday for our internal teams in particular. We've really pushed this database service to some very high levels of throughput and performance requirements. It's also true of Keyspaces, by the way. So these databases are able to scale to extremely high loads and then descale without any disadvantage to you. And it's really nice to know this, even if your scaling requirements aren't anticipated to be particularly large or particularly variable. It's just nice to know that that is not going to be something that you're going to have to deal with. You won't have to think about changing instance sizes or ordering different sizes of hardware and deploying that in racks, for example. We have a lot of customers who actually will have workloads that are running along at maybe 50 requests per second, and that's their normal type of a workload. And then they'll have some kind of a requirement where they're going to release a new product. Maybe there's an ad campaign, and they will literally need to scale up to be able to handle hundreds of thousands of requests per second, maybe just for a few hours. And once that's done, they want to descale again. And in many traditional self-managed database scenarios, what ends up happening is that you basically look ahead at what's going to be happening in the foreseeable future, and that might be a year or 2 years, and you try to provision for that. So you purchase all of this hardware, this infrastructure, and you're committed to it. And while some databases give you the ability to descale or change things, it's not often done, right? People see risk associated with descaling, and maybe there's another peak coming. With DynamoDB and Keyspaces, we can handle up to millions of requests per second, and descale that whenever you need to, and that's all you have to pay for. We can carry trillions of items. We have tables that are supporting petabytes of data, and we're going to deliver that single-digit millisecond read and write latency experience, no matter what type of throughput you're driving or how much data you're storing. And this is really nice. There's no tightly coupled connection between your I/O, your throughput, your storage volume, the amount of memory or compute that you have on a particular server. You'll note that there is no consideration around a server or a size of a server here, and no fixed ratio of amount of storage per compute, for example. This is really a game changer, and unless you have experienced this kind of a serverless scenario, it's really difficult to see the level of benefit that customers get from this. So here's an example where clearly this is a load that we've generated. It looks like some kind of a benchmark where we've got some reads that are indicated in blue, and then some write activity indicated in orange, and we ramp this up over time and then let it trail away. So we're actually scaling this from 0 to millions of requests per second over a period of time. And the interesting thing is, when we look at the graph on the right, we see a really nice, consistent low latency. We see maybe around a millisecond of variance, and it really doesn't change too much. In fact, if anything, it stabilizes and becomes more consistently low when you drive harder load, more and more load at this database. So these are the kinds of properties that bring people to DynamoDB and Keyspaces for their most critical workloads, the things where the latency experience will define the overall experience of their customers, and it's critical to their business that they deliver a responsive experience for their own customers. So what about developer efficiency, Gautam?
Sure. So both DynamoDB and Keyspaces are serverless solutions, meaning you don't have to manage, provision, or patch any of your servers, or you don't have to install, maintain, or operate any software. The serverless solutions abstracts the complexity of node-level understanding, makes it really easy for developers to maintain and scale the system whenever required. So no servers to manage means your databases are maintenance free. Think of all other things you could do if you don't have to manage all this, what you see in the slide here: security, durability, and availability of your data, and then performance, scale, and agility of your applications. So it all comes packaged as a fully managed solutions. The developers can now focus on building applications and improving user experience rather than managing database software or infrastructure. And coming to the management overhead involved, so to ensure availability, durability, and security of your self-managed databases doesn't exist with Dynamo or Keyspaces. So with both the services, data is replicated automatically across multiple AWS availability zones within a region using a default replication factor of 3. And there is a availability SLA of 4 nines within a region. And even though both Dynamo and Keyspaces are serverless, and we are responsible for the undifferentiated heavy lifting associated with both operating and managing the infrastructure, we do publish a set of metrics in CloudWatch that can help you understand the interaction of your evolving workloads with the tables, like the capacity utilization, user errors, throttles, or performance latencies. So you can use these metrics in CloudWatch to build out your own dashboards and CloudWatch alarms to create a solid operational awareness around your data in the cloud. Then there are a lot of built-in security features. Data is encrypted at rest by default using the keys stored in AWS KMS, Key Management Service. It protects traffic in transit using TLS for all connectivity. And the services are integrated with IAM to help you manage access to your tables and data. So if you want even more security, you can use VPC endpoint to connect your VPC resources to the tables in DynamoDB or Keyspaces instead of using the public zone endpoint. Then if you have auditing requirements, you can log all your administrative actions to your resources using AWS CloudTrail. And especially with DynamoDB, we recently launched a feature by which you can log all your data plane operations in AWS CloudTrail. This is another interesting feature with both DynamoDB and Keyspaces. The backup and restore process is made much simpler using point-in-time recovery. We call it PITR, P-A-T-R. When PITR is enabled on tables, we continuously capture all the changes happening to your table, and we squirrel them away to be available for a period of 35 days. And when you want to restore a table, you just pick a time, that is any second in the last 35 days that you want to go back and click on restore. What we do is we don't overwrite your production table, but instead we restore a copy of the table to a new table as of that point in time. So whatever the item you might have either overwritten or lost, you can go to the new table, fish it out, place it back in your production table, or you can switch your application to use the restore table later. The best part about this backup and restore mechanism is it does not impact your production workloads in any way or the availability of your tables, as we manage these backups and restores in a separate set of systems for you.
Yeah, the backup and restore I think is really quite magical. Knowing how difficult that can be in a massively scaled or highly distributed database, being able to just take care of that so easily is a game changer. So, Gautam, one thing I want to touch on here is that, when we look at what we've discussed already in this session, clearly DynamoDB and Keyspaces have a lot of the same kinds of fundamental properties around things like scalability and availability and these kinds of things. And in my background, having worked a lot with DynamoDB over the years, we've seen a lot of customers who were using Cassandra and managing Cassandra themselves. And as things got, started to scale out, it just became such an operational burden that they would migrate to DynamoDB. And when I look at that and I think about the data modeling and the structure of the data and so forth, there's some differences between the stores, but oftentimes you could look at Cassandra or Keyspaces and DynamoDB and think, you could actually solve for many of the same problems, either using Keyspaces or DynamoDB. So one question that might come up is, given that we have DynamoDB, why build Keyspaces? Why did we decide to create an AWS service for a Cassandra compatible database?
Sure. Yeah, I think that question is something we hear often in the last 1 year, right? But to answer that, I think we need to step back a little and understand what Apache Cassandra is and the challenges of running Cassandra. So a quick overview of Apache Cassandra. It's a very popular open source white column data store. It's commonly used for large scale applications that require fast read and write performance. And one other reason it's popular is for the developer experience it provides. Developers familiar with relational databases can bring their knowledge to Cassandra and use the SQL Cassandra query language to build applications. But despite its scalable architecture and developer experience, Cassandra does come along with some key challenges. To start with, implementing and configuring Cassandra requires specialized expertise. It's not just about the knowledge of distributed systems, but Cassandra has this multiple layers of caches, Bloom filters, compactions, garbage collections, and so many processes. The clusters need some fine and regular tuning to ensure good performance. Second, it's complex to scale Cassandra clusters up and down. Cassandra does not scale down easily. Like every single legacy NoSQL technology, customers have to provision for peak and leave it there most of the times. Then upgrades are kind of tricky because Cassandra has so many concepts and moving parts. Upgrades are normally done in a rolling fashion with each rack, and there are no guaranteed mechanisms for a successful rollback. Then it lacks enterprise features like data encryptions, backups, and restore. So that's something the users have to manage it themselves, which requires significant manual effort. Lastly, like any self-managed database, of course, there is administration overhead involved. Not to forget about the licensing cost if you're using enterprise versions of Cassandra. So to overcome these challenges, customers have always asked us for a solution to run their Cassandra workloads in AWS that has all the benefits of Cassandra, but maintenance free.
Yeah, I think this is something, when you think about Keyspaces, I'm really excited about this because, for customers who are, sometimes they're buried under the operational load of managing Cassandra themselves, and Keyspaces represents a really nice, easy step to take to offload some of that heavy lifting and not actually have to adapt their application layer. Super cool.
Totally. And that motivation, right? And it led to Amazon Keyspaces, a scalable, highly available, and fully managed Apache Cassandra compatible database service. The key benefits provided by the service are those we addressed earlier, like it's serverless, so no servers to manage. There is performance at scale, and it's highly available and secure. But what do we mean by compatible with Cassandra? So Amazon Keyspaces works with your existing SQL code for reading and writing data. You can run Cassandra workloads on AWS using the same drivers and developer tools like SQL SH or DS Bulk that you use today. You can refer to our documentation page that offers step-by-step instructions on how to configure different Cassandra drivers to connect to Amazon Keyspaces. We also have a nice blog post on how to fine-tune a tool like SQL SH when loading data into Keyspaces. To your clients and drivers, the Keyspaces look like a 9-node 311 Cassandra cluster because the driver needs these IPs to connect. So any open source driver that works with Cassandra 311 will work with Keyspaces. And there is also backward compatibility available for previous Cassandra versions, just like what's offered in Cassandra 311. So Pete, I think we covered the features and the reason on why we decided to launch Amazon Keyspaces. Do you want to quickly summarize on the use cases when customers should be thinking about DynamoDB?
Yeah, absolutely. And there's always exceptions, but really, what we're looking to do here is to give just some general context about when you would consider Amazon DynamoDB and when you would consider Amazon Keyspaces. For DynamoDB, the service has been around a long time, since 2012, and it's had a lot of time to evolve and mature. One of the things that we do have with DynamoDB is an ability to move really quickly in terms of brand new innovations, things that maybe we have internally as a big idea, something that we want to take a chance on and move data storage, particularly NoSQL databases and distributed stores to the next level. As an example of that, we now offer atomic multi-item transactions. So those are across partitions and can even be across tables in the same region. So that's a very powerful thing and actually fairly unique, the way that we've implemented across the NoSQL database industry. We also offer multi-region active storage. So our global tables feature allows you to essentially replicate a DynamoDB table in multiple regions in an active configuration, and we handle all of the conflict resolution there for you. We also have DynamoDB Streams, which is a really nice change capture feature that allows you to have a Kinesis client library compatible stream reader and build really event-driven data flows, or to replicate from DynamoDB into different stores. We have an API compatible right through in-memory cache, which is called DynamoDB Accelerator or DAX. And that's something that we've been able to innovate pretty quickly on for DynamoDB. The other thing about DynamoDB is where you want an operational database that offers really deep integration with other AWS services. And you'll notice here I'm really talking about the serverless APIs or AWS services in particular, because DynamoDB is very often built into these serverless architectures with API gateway, amplify, and also using triggered Lambda functions as part of an event-driven workflow. So really with DynamoDB, it's an opportunity to get to something that we've been evolving as a serverless option for quite a while now, and where AWS can really move in directions that we want to take things very quickly without having to think about compatibility with a broader project, if you like. So, Gautam, what about Keyspaces? I mean, we've already mentioned that it just takes so much of the pain away from operating your own Cassandra databases. But what extra context can you give us here in terms of when people really ought to be thinking about Keyspaces as their next step?
Sure, yeah. So I would say the choice is more about skill set. If you want to migrate existing Cassandra SQL applications with less code changes to a fully managed AWS solution, then yes, Keyspaces. It basically provides a quickest path to modernize your Cassandra databases, and you can do it by performing a lift and shift of your workloads with very minimal code changes, and there is no entire refactoring involved. On the other hand, if you're building new applications and you require a highly scalable serverless data store that also supports open source APIs, then definitely Keyspaces, I would say. And apart from this, it's also important to remember Keyspaces is not just hosted Cassandra, but it gives you an entire serverless experience. And it not only provides the features of Cassandra, but there are a lot of enhancements included, like there is stable level isolation, there is support for wider partition, inbuilt data replications, and more security features like encryption that comes as packaged. So though we have these two services with a lot of similarities, there is constant innovation happening on both sides, with each of them developing and evolving independently. So Pete, how is DynamoDB evolving?
Yeah, I think that's a really important point here. Obviously, there's a lot of things that we found with DynamoDB were really important for customers in terms of removing the heavy lifting, and you see a lot of what we've learned with DynamoDB kind of built into the core of Keyspaces also, because they're common asks, right? All customers love that completely serverless, hands-off experience. So, but it is important to know that these are different products, and at AWS, much of what we're doing with our products is based on customer asks. So these services are going to continue to evolve, and they're both innovating at quite a rate. It's really about what customers want. Just to touch on some of what DynamoDB has been doing lately, here is a list of some of the more recent updates or feature adds. I'm just going to touch on a few of these because I think it's worth being aware of these. If you're familiar with DynamoDB, these new announcements make a big difference. The first is CloudTrail logging of data plane activities. So we've always been able to log to CloudTrail any kind of what we call control plane activities, things like deleting a table or changing the capacity or something like that. But actual data plane activities like reads and writes were not something that you could log easily. That has changed recently, and now you can log all of those data plane activities. And this is really important for customers in particular industries who have strong requirements for auditability of these kinds of activities. We also added direct integration with Kinesis data streams. So in some cases, Kinesis data streams provides a richer experience for things like streaming analytics and direct integration with Firehose and a lot of these things that customers find useful. We were seeing customers essentially, in some cases, reading from a DynamoDB stream only to then place these records in a Kinesis data stream. So we wanted to make that easier and more direct, and so that's what we did. The third item here, I think, is really amazing. Glue Elastic Views is a new service in preview at the moment. I'd encourage you to take a look at that. What it will do is enable you to read from one data store and continually replicate then into a secondary one as a materialized view. So in context of DynamoDB, you could imagine having a serverless tool which is really easy to define propagation with, again, using a SQL-like language, to basically say, I want DynamoDB to be my front end, my source of truth, but I have these other views that I want to materialize in different indexing technologies, and that might be Elasticsearch, for example, to be able to do full text fuzzy search. So Glue Elastic Views will be able to solve this for you across a number of different data stores, and it's completely hands-off and serverless. So this is really a game changer, I think, in terms of effort associated with building these polyglot persistence models, where we're using different types of indexing for the same data, different views. We've updated our pricing calculator, making it easier to come up with pricing estimates. Contributor insights is something that we worked on with the CloudWatch team to enable you to get near real-time views into top talkers for your DynamoDB table. So where are the requests going? How are they distributed? Are they nice and evenly distributed as we expect, or are some of our items more popular than others? Also really great for diagnosing throttling, where we have particular keys. Maybe the shape of our load has changed, and we need an insight to understand what's going on there. There's a lot of other stuff here. I don't want to go into all of them in detail. I will touch on data export to Amazon S3. This is another amazing feature. When you have your point-in-time recovery enabled for your table, you can now use this essentially to do a restore, not into a DynamoDB table, but you can restore essentially into S3 objects. So this becomes a non-intrusive, very simple way to export your DynamoDB datasets to S3, maybe for warehousing. If you think about this, you know, a data store like Keyspaces or DynamoDB can grow to massive scale. As I said, we have customers that have multi-petabyte tables. A point-and-click simple way to export all of that to S3 is really kind of astounding. The last thing I want to touch on is that we added support for Particle recently, and that's a open-sourced SQL compatible language for querying your data. The nice thing about Particle is that it really supports different data structure upfront, right? It's very easy to use. It looks and acts like SQL, but it allows you to work with either fully structured data or documents or any type of data. So for a database like DynamoDB that has flexible schema, it's really important. But beyond that, it means that people who are familiar with SQL, developers who've you know, lived and breathed SQL for most of their careers, are able to describe their data operations for DynamoDB in a SQL compatible language that makes it easier for them to adopt DynamoDB. They no longer have to spend any additional time upfront learning the new APIs that are associated with DynamoDB in the past. So some really, really great new things. If you've looked at DynamoDB in the past, make sure you go take a fresh look at it, because it's constantly changing and adding new functionality based on customer asks. That's what's happening with DynamoDB. Gautam, I know there's a ton of things happening over on the Keyspaces team too. What's new for Keyspaces?
Sure. Similar terms like DynamoDB, right? We always listen to customer, and most of our roadmap is driven by customer feedback. So with Keyspaces, we continue to invest on features to provide deeper Cassandra compatibility to enhance the security and availability features of the service more than where it is today, and to ensure a better developer experience. So the Keyspaces is available in all AWS commercial regions, and there were around 23 new feature launches since the service went GA in April last year. To quote some, Keyspaces is integrated with AWS CloudFormation, so you can create templates that describes your table and let CloudFormation take care of the provisioning and configuring those resources for you. Support for counters and static data types are available too. Also, you can use VPC endpoint powered by AWS Private Link to provide even more secure connectivity between your tables in Amazon Keyspaces and your VPC resources. We covered about point-in-time recovery already. And then you can use authentication plugin for different open source drivers. And this plugin enables IAM users, roles, and federated identities to add authentication information to the API request you send to Keyspaces using AWS SIG v4 process. NoSQL Workbench is another interesting tool. It's just a client-side application that can work with different operating systems. You can download it for free from our documentation pages. And using the tool, you can model your Cassandra tables and you can visualize your designs before taking it to production. And some of the recent launches are we have JSON support now. You can read and write JSON documents more easily by supporting JSON syntax for insert and select operations. And finally, Keyspaces is now PCI DSS compliant. But I would like to point out, right, even with all these features, the service team is still heads down working on more and more features for this year and next. So you should see more features coming up in the very near future.
Yeah, one of the things that I love to hear from customers is when they're overjoyed that the data store that they're using, the database that they've chosen, just gets better without them having to do anything. There's this constant innovation and improvement of these services that customers can benefit by without having to lift a finger. So
yep.
Pretty great. If you're ready to get started, if you're thinking about how do you adopt this purpose-built strategy, and particularly in the case of DynamoDB and Keyspaces, how do you tease apart what you already have, and how do you choose when to apply them? Where do you get started and start getting some traction? I guess there's really two different scenarios here. The first one would be look for a new workload. Maybe you have some new application that you're going to be building, and that's a prime opportunity right there to take a good look at the whole range of AWS databases and think about which is the right fit, or actually maybe it's multiple databases that will allow you to optimize the performance of your application from multiple fronts, right? So that's a fairly simple, cut and dry type of a opportunity to apply these new data stores or different data stores that maybe you haven't worked with before. The second opportunity that we see a great deal is, we have some pretty amazing relational database options at AWS. I really love Aurora. And there's a Postgres engine and a MySQL engine. We see a lot of customers who are running legacy relational databases that maybe have commercial licensing that they're not happy with anymore, and they want to move forward and get to a relational database service that is more managed, right? That takes the heavy lifting away, as we've talked about a lot in this session already. So in those kinds of cases, where customers are very often looking to migrate and move forward, go to something like Aurora. Anytime you're looking at a database migration and investing in that move, shifting a lot of that data and kind of refactoring along the way a little bit, that's another opportunity where you should stop and think, is there an opportunity here where at least part of what I'm doing would benefit from some other indexing technology, and that might be DynamoDB, it might be Keyspaces, it might be Graph, it might be Neptune, right, which is another awesome AWS database. So don't miss those opportunities either. When you're thinking about modernizing in that regard, that's another possible place where you can bring some of these other AWS database technologies to bear on really moving your application forward in a big way. So that would be my advice. I don't know, Gautam, if you have anything to add on that.
Sure, I think you really summed it up very well, Pete. So yeah, if you're building modern applications or having self-managed NoSQL database or relational database with access patterns fit for a NoSQL, and you're looking to switch for these feature requirements that you see on the right side, that is high performance, availability, scale, better TCO or a serverless architecture, it's time to start considering either DynamoDB or Keyspaces. So with that, let's move on to some Q&A.
All right. So we'll be here to answer questions. Please do post them in the chat. Hopefully we can cover all of the questions while we have time. Thanks everybody for joining us.
Yep. Thanks all.